Okay, good evening all. Am I audible? Please confirm in the chat box, everyone. Is someone confirm in the chat box if I'm audible or not? Yes. Okay, thank you, Manohar. So let us start the session, guys. So where are we? Probability, right? So this is our third class in the probability, guys. We have done two classes earlier. So we discussed the probability of marbles. We checked with a single marble, two marbles, as well as three marbles in the previous class. Okay, so now we will be discussing another concept, guys, probability of coins. Okay, we have done probability of dice, marbles, and probability of odds. So now we will be doing probability of coins. Another important concept in the probability, guys, that is probability of coins. So let us see how does this work, a probability of coins. Okay, suppose, guys, if I toss one coin, I can toss one coin or two coins or three coins, coins, 5 coins, likewise n coins. Now tell me, what will be the total number of cases if I toss one coin? What are the total number of possibilities if I toss one coin, guys? Anybody? One coin. No, Karthik, in app we don't have, buddy. Today it will be only in the YouTube. Okay, today it will be only in the YouTube. Today no in app. Tomorrow we'll be having in the app. Okay. So when I toss one coin, guys, how many cases I can get? Two cases. Only two cases. Which are those? Heads or tails. If I toss two coins, what will be the cases? I can get both heads. I can get heads and tails. I can get tails and heads. I can get both tails, which means we will get four cases. Likewise, if I toss three coins, I can get all heads, or I can get heads, heads, tails, or we can get heads, tails, heads, or tails, heads, and heads. Okay. Uh, Guys, is there problem with the voice? Is there problem with the voice? Can someone confirm? I think you need to change the settings, people. I think you need to change the settings, guys. Check the audio quality. Keep the audio quality, people. Check the audio, I mean video quality on the top. See, if you see in like this, here there will be three buttons, people. On the top, if you click on that, you will get video quality. Go to the advanced and keep it to above 360. 360 or above 360. Then it will be clear. Okay. So now let us see further. So what else I can have here, guys? I can have two tails and heads. I can have tails, heads, and tails, or I can have heads, tails, and tails, or I can have all tails. So how many cases I can get here? 8 cases. So if you see, one coin, two cases, two coins, four cases, three coins, 8 cases, four coins will be 16 cases, five coins will be how many? 32 cases. So what is happening here, people? This is 2 power 1, this is 2 square, this is 2 cube, this is 2 power 4, this is 2 power 5, and finally this is a 2 power n cases. If there are n coins, then there will be 2 power n cases. Okay, just give me a second. Just give me a second. Okay, observe, observe. Now guys, now check. Now audio clear for everyone. Confirm one last time. Is audio clear now? Is audio clear now for everyone? Please confirm in the chat box. Yes. Okay, okay, fine. So let us get back and see what is happening here. So let us deal with, okay, three coins. When I toss three coins, what happens? Suppose if I ask you what is the probability of one heads. Now you check. Or let us say probability of three heads. Probability of three heads, if I say, Three heads, we can get it in only one case. We can get it in only one case if you see here. So that is 1 by 8 is the probability. One favorable case out of total 8 cases. This will be same for probability of 3 tails as well. Probability of 3 tails as well, it will be 1 by 8, right? Suppose, if I talk about what is the probability of 1 heads. 1 heads, where all I am getting, guys, if you see, these are the only cases where I am getting 1 heads. How many cases? 3 cases out of 8. If you observe carefully, this is also same as probability of 2 tails. Why? When you are tossing two coins, you are getting exactly 1 heads, means remaining 2 coins will be what? Tails, right? So whenever you are getting 1 heads, this is also same as probability of 2 tails. So the probability is a 3 by 8. Likewise, if I ask a probability of 1 tail, now that is also exactly 3 cases, 3 out of 8, which is the same as a probability of 2 heads. Now, I have written everything here. By looking at that, easily we can answer. But do we really have to look at it? Observe that carefully. 1 heads means where can I get people? Either in the first coin. When I say probability of 1 heads, that 1 heads we can get it in the first coin, or in the second coin, or in the third coin. How many cases? Exactly 3 cases. So 3 favorable cases. Even when I say probability of 1 tail, so where all I can get that 1 tail? Even in the first coin, or in the second coin, or in the third coin. So how many cases? 3 cases once again. Suppose if I deal with, let us say probability of 4 coins. If we deal with the probability of 4 coins. So suppose if I ask all heads, 4 heads, this will be same as probability of 4 tails as well. That is equal to, there will be only one such case, guys. Out of total cases 16, this is simple. Now suppose if I ask you what is probability of 1 heads, you tell me answer for this. Probability of 1 heads, what will be the answer? Anybody? Probability of 1 heads. Exactly, 1 by 4. How do we get it? 1 heads means where can I get? I can get it in the first coin, or in the second coin, or in the third coin, or in the fourth coin. Means 4 favorable cases out of total 16, which is 1 by 4. So this is also same as a probability of 3 tails. It means if you are getting 1 head, means obviously you are getting 3 tails. Likewise, suppose if I ask you what is the probability of 1 tail, this is also 4 by 16. Why 1 tails? Where do I get that 1 tail? In the first coin, or in the second coin, or in the third coin, or in the fourth coin. So 4 favorable cases out of 16 cases. So that will be what a this is same as probability of 1 tail, and this is also same as probability of 3 heads. Even if I ask for probability of 3 head, answer will be same. Now, suppose if I ask probability of, what is a probability of 2 heads? How do we calculate that? This is a little tricky part. Observe. How can we directly calculate that? Is 2 heads means I take any one possibility. Head, head, tail, tail. Or I can get it as head, tail, head, tail. And likewise, many cases. Use the concept of forming words here. Look, how many letters are there? 4 letters are there. 4 factorial ways we can rearrange them. Divided by repetition, 2 heads, and a repetition, 2 tails. So if you do it, you will get exactly 6. So this will be 6 by 16. What is my answer? 6 by 16. You will understand it. I am repeating it. Listen to me carefully. So if you want to directly calculate this, how can we calculate it, guys? You want 2 heads. You're tossing 4 coins. 2 heads means what? You will be having 2 heads and 2 tails. So totally how many favorable cases are there? We can calculate them using the concept of forming words. 4 letters, we can arrange them in 4 factorial ways. Again, repetition. Two heads are 2 factorial and two tails are 2 factorial. You'll understand this better if I talk about 5 coins. Observe. If I talk about 5 coins. Suppose when we toss 5 coins, what is the probability of 2 heads? I ask. What do we do? Take one arrangement, 2 heads, something like this. Rearrange it. What do we get? 5 letters are there, 5 factorial. Divided by repetitions is what? 2 heads, 2 factorial, 3 tails, 3 factorial. So if you solve this, we will get a 10. So 10 favorable cases out of total 32 cases. Why? 5 coins means what? 5 coins. So we are tossing 5 coins now. 5 coins. 2 power 5 is 32, totally 32 cases. Suppose let us say if I talk about 6 coins. If I talk about 6 coins, what is the probability of, let us say, if I talk about 4 heads? 4 heads. What do we do? We take one example. 4 heads. Remaining 2 coins will be 2 tails. We rearrange them. What do we get? 6 letters, 6 factorial. Repetition. 4 factorial by 2 factorial. If you solve this, we should get 15. So favorable cases are 15. Total cases, 6 coins means a 2 power 6, that will be 64. So it doesn't matter whatever be the number of the coins, people, we can simplify like this and we can directly get the answer. Did you understand this concept? Did you understand this concept, everybody? So far, whatever I told you, did you understand this? Okay, fine. Yeah, good. Next, let us see. Suppose, suppose if I ask, let us say 6 coins are there. What is the probability of getting at least 4 heads? I say at least 4 heads. If I say, what is the meaning of this, guys? At least 4 heads. It means I have to get a minimum of 4 heads. It means I can get 4 heads or 5 heads or 6 heads. How do we solve this? Okay, careful. Careful. 4 heads means take one arrangement. We already did that. Head, 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 tail, tail. You have to rearrange it. That will give us what? 6 factorial by 4 factorial into 2 factorial, which is 15 cases. Or, or 5 heads means what? Head, 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 tail. So that becomes what? 6 factorial by 5 factorial into 1 factorial, which is exactly 6 only. You can actually directly write that, people. 5 heads. What is the meaning of 5 heads? 5 heads is also nothing but one tail. It is also nothing but one tail. One tail, where can I can get it? I can get it in first coin or second coin or third coin or fourth coin or fifth coin or sixth coin. It means exactly 6 cases. And I get all heads. All heads means we'll get it in only one way. Divided by what is the total cases? 64. This will be my answer. So what do we get here? So this is a 22 by 64. You can further simplify it. You'll get 11 by 32 is my answer. Am I clear with this question, everybody? Did you understand this question, everyone? Everyone, please confirm. Please confirm, everybody. Please confirm, everyone. Did you understand this? Okay. Yes, guys. Good. Next. Suppose in the same 6 coins, guys, if I ask a question in this way, what is the probability of at least one head? What is the probability of at least one head? Now, guys, don't do it as one head or two head or three head or four head, something like this. Manohar, look, what is happening? You look at this. When I said 4 heads, least 4 heads. What is the meaning of it? I can get 4 heads or 5 heads or 6 heads. 4 heads means I take one arrangement. 4 heads and 2 tails. How do I arrange it? Totally 6 coins, 6 letters, 6 factorial by repetition. 4 heads, 4 factorial into 2 tails, 2 factorial. So if I do that, what do I get? 15 I'll get. That's what I wrote here. Or I can get 5 heads. 5 heads means what? I can have 5 heads and 1 tail. How do I arrange it? 6 letters, 6 factorial divided by 5 factorial into 1 factorial. If you solve it, that will be 6 cases. Likewise, 6 heads, you will get it in only one case. All heads you'll get it in anyways one ways. Divided by total cases 64. Did you understand, Manohar? Did you get it now? Yes, did you understand this? Okay. Guys, just don't keep on just attending the classes, guys. There are too many free tests. Look, if you check your app, guys, in the app, if you see, there is something called three buttons in the home screen itself on the top. If you check here, there is something called free tests. Please keep on attending the tests, guys. The more tests you take, it will be more easier for you. So please take the test. The solutions are also provided at the end of the every test. So don't neglect. The more tests you take, guys, the more perfection you get. Okay, so fine, let us go. At least 1 heads means don't do 1 heads or 2 heads or 3 heads and something like that. What you can do is at least 1 heads means you can get 1 head or 2 head or 3 head or 4 head or 5 head or 6 head. Which one you don't want? You don't want 0 heads. Exactly, Chandana. Very good. What do we do? This is a maximum probability minus 0 heads because we don't want 0 heads. Maximum probability is what? 1. 0 heads. 0 heads is what? You'll get 0 heads in only one way out of total 64. If you do this 63 by 64, think about it, guys, directly. Totally 64 cases are there. There is only one case where you get 0 heads. All heads you'll get it in only one case. Remove that case. It means all remaining 63 cases are your favorable cases divided by total 64 cases. Am I clear with this now? Did you understand this question? Did you understand this question? Everyone. Okay. Yes. Next. Next. Observe. So this is all about coins, guys. Okay. This is about coins. Now let us go to next concept, that is cards. Another interesting one. What is the concept? Cards. Tell me, how many cards will be there in a deck of cards? How many cards will be there in a deck of cards? Anybody? How many cards will be there in a deck of cards? 52. So there will be totally 52 cards, guys. You must know the classification first. Now these 52 cards are divided into two colors. They are divided into what, people? They are divided into two colors. So which are the colors? The colors are red and black. There are two colors, guys. They are red and black. Now there will be 26 red color as well as a 26 black color. 52 cards are divided into two types. They are red and black, right? So now there will be four suits. Which are those? In red, we have hearts as well as a diamonds. In black, there will be two suits. They are spades and clubs. Observe. Once again, all will be 13 in number. 26 red are there, in which 13 are hearts, 13 are diamonds. So 26 blacks are there, in which 13 are spades and 13 are clubs. Okay. So now, what all the different cards we will have? If you see, guys, we will start with the face cards. We have something called face cards. Which are the face cards? We will be having king, queen, and jack. In diamonds as well, we'll be having king, queen, jack. Here also king, queen, jack. Here also king, queen, jack. Next, we will have something called ace cards. Ace cards. Look, few people combine ace cards with the face cards people. That is wrong. Ace cards are different. They are not face cards. So every suit will have one card. Likewise, next we will be having number cards. Those number cards. So number cards, which are those? 2 to 10. 9 cards will be there, 2 to 10. Now observe carefully. Every card is exactly 4 in a number. So look, how many different types of cards are there? Check out. King, queen, jack, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally, how many types of cards are there? 13 different cards. So we have totally 13 different cards. Now, if you see, every card is exactly 4 in number. There are 4 kings, 4 queens, 4 jack, 4 ace, and 4 twos, 4 threes, likewise 4 tens. So totally 13 into 4. How many cards? 52 cards are there. So how many face cards are there exactly? Face cards, if you observe, face cards. So 3 face cards in each suits, 4 suits, 3 into 4, 12 face cards. Number cards are 4. Sorry, ace cards are 4. Number cards 2 to 10, 9 in each suit, 4 suits, 9 into 4, 36 number cards. If you add them exactly, you will get 52. So this is the entire classification of number. What is that? Cards. Did you understand? Did you understand? Classification of cards. Everyone, did you understand the classification of cards? Okay. Good. Let us continue. Let us continue further. Suppose, suppose if I ask you question, let us start with the questions. Suppose, let us say, let us deal with picking 2 cards. Picking 2 cards. Tell me, out of 52 cards, out of 52 cards, if you are picking 2 cards, what will be the total number of cases? What will be the total number of cases picking 2 cards out of 52 cards? Anyone? Anyone? 52 C2. Perfect. Suppose if I ask you, what is the probability of getting both face cards? Check out. Total cases we know 52 C2. Now check out how many face cards are there? 12 face cards. We need 2 out of them. So what will be the favorable cases? 12 C. That's it. Picking 2 face cards out of total. What is the probability of getting both the cards as face cards? Means 12 C2 by 52 C2. Suppose if I ask you, what is the probability of getting both both number cards? Both number cards. Total cases are 52 C2. Number cards are totally 36, out of which we need 2. So out of 36 number cards, you need 2 number cards. Means what? 36 C2. 36 C2 out of 52 C2. That's all. Suppose if I put you in something like this, probability of Non-face cards, probability of non-face cards. None of the cards must be face cards. So total cases will not change, that is 52C2. Can anybody tell me what is the favorable cases here? What are the favorable cases? I want non-face cards. Let us see, can anybody answer? Perfect, guys. What is it? 40C2. Why? Out of 52 cards, we have to remove face cards. So 12 face cards, will remove them. What will be there still? 40 cards will be there and we will be selecting 2 cards. So that is 40C2. Okay. Suppose if I ask you, let us say, what is the probability of exactly one face card? Carefully here again. Total cases will not change 52C2. I need one face card, but we are picking 2 cards. We are picking 2 cards. I need one face card and one any other card apart from face card. 12 face cards are there. I need one out of them, that is 12C1. And my next card can be any other card apart from face card. So I can get ace as well as a number. How many are there? 40 are there. From those 40, I can get any one. 40C1 is the answer. Okay, 40C1, 12C1 into 40C1. Chandana, it is not R. You are picking 2 cards. You need one face card and any other card. If you put or there in between, one face card or any other card, means you are picking only one card there. Careful, we are picking 2 cards here. We are picking 2 cards. So that's why one face card and one any other card. Okay. So now I will give you, you try this question. Exactly similar question I'll give you. Exactly one number card. You give me the answer. Total cases will not change. Just tell me favorable cases. That is sufficient. Anyone. That's it, Prashant. I need complete favorable cases. Complete favorable cases. 36C1 and 16C1. Right answer. You need one number card and one any other. One any other. Number cards are 36. I need one among them. I need 36C1. And means multiplication. One any other card means the other card we can get it from face cards and ace cards. Totally how many are there? 16 are there. From them I need one. My answer is 16C1. That will be my final answer. Okay, so let us pick. Okay, another question in this. Probability of neither a spade nor a heart. Tell me the answer. Neither a spade nor a heart. Anybody? Probability of neither a spade nor a heart. Guys, you're understanding. Don't forget to like the video, people. Don't forget to like the video, guys. Okay, that's my sincere request. And another thing, if you still did not subscribe to the channel, please do subscribe and please inform other friends of yours, guys. Okay, what is the answer? 26C2 divided by 52C2. Why? I have to remove spades and hearts. Spades are 13, hearts are 13. I cannot select from them. It means I have to select from diamonds and clubs. How many are there? Diamonds and clubs together? 26. From those 26, I can select any of the 2 cards. So what is the answer? 26C2 divided by 52C2. Now careful, now careful. One last question in this. Probability of neither a heart nor an ace. Let us see. Who will give the right answer for this question? Neither a heart nor an ace. Neither a heart nor an ace. Anyone, anyone, anyone? Waiting for your answer. Manohar says 36C2. Anybody else? Anybody else? Good. 36C2 divided by 52C2 you will get. Why? No, Naina. Check it, check it, check it. I said neither a heart nor a space. It means totally 52 cards are there. 52 cards are there. Out of them, neither a heart means you have to remove all the hearts. How many? 13. What is left over? 39 cards are there. From this 39 cards, you need to remove all the hearts. How many hearts are there? 4 hearts are there. Sorry. You have to remove all the ace cards. How many ace cards are there? 4 ace cards are there. But you will be removing only 3. Why? When you remove all the hearts, see, you removed all the hearts here, 13 cards. In that, one ace is gone. Still 3 ace cards are there. We have to remove remaining another 3 cards. So 39 minus 3, 36 will be there. Out of these 36, we need 2 cards. That is 36C2 divided by total 52C2. Am I clear now? Did you understand this question? Did you understand this question? Everyone, everyone. Okay. Next. So that is about the probability of the cards, people. Yes, you can still, if you want, deal with the 3 cards also, but this is absolutely same as our marbles. If you know concept of the marbles, guys, this is pretty simple. So one final concept in the probability, guys, that is probability of numbers. Probability of numbers. Observe. Suppose, let's say, if I give you question something like this, let us see. Pick a number. So lock this on. Pick a number from first 100 natural numbers. From 100 natural numbers. Okay. And then find the probability of pick a number from the 100 natural numbers and then find the probability of first question in that. Find the probability of getting an even number. Pretty simple question. Anybody answer? Probability of even number. What is the probability of getting even number? 50 by 100. So 50 even numbers are there. 50 favorable cases divided by total cases 100. Very simple. Agree? Suppose if I ask you, what is the probability of getting a prime number? Look, if you don't know this, remember 1 to 50, 1 to 50, there are 15 primes, and 51 to 100, there are 10 prime numbers. So what will be the answer now? 25 out of 25 out of 100. 1 by 4 is the probability. Okay, if you don't know this, please try to remember 1 to 50, there will be 15 primes. 51 to 100, there are 10 prime numbers. Suppose if I ask you, what is the probability of multiple of 3? What is the probability of multiple of 3? Let us see who will give the right answer. How many multiples of 3 are there in the first 100 numbers? Multiples of 3, guys. Good, Manohar. How many? 33 are there. If you see 3 into 3, 99. If you go beyond that, Prashant, check it. Only 33 are there, buddy. So 33 are there out of 100. Tell me. Probability of getting, what is the multiple of 4? Multiple of 4. Now this will be easier, guys. You understood. Multiple of 4. Anyone? How many multiples of 4 are there? Just divide 100 with the 4, guys. Whatever the number you will get it, that's all. Bhumika, how many multiples of 3 are there? 3, 6, 9, 12, so on. Final multiple will be 99, right? Instead of that, directly divide 100 with the 3. 3 into 3 is 33. If you go further, 3 into 34, that will become 102. Right? So that's all. That's why 33 multiples. Suppose if I want multiples of 4, you just divide 100 with 4 because we are talking about first 100 natural numbers. So 100 by 4, how many are there? 25 you will get. 25 by 100. Okay, did you get it, Bhumika? Understood that? Understood? Next, multiple of 15. Tell me, what is the multiple of 15? Multiple of 15. If you know 15 table, immediately you can answer, guys. Okay, buddy. What is it? 6. Exactly. 6 by 100. 6 by 100. Okay. Suppose if I ask you, what is the probability of multiple of, let me write here, probability of multiple of 3 or 4. Multiple of 3 or 4. Carefully here, let me explain. Total cases will be 100. Guys, multiples of 3 or multiples of 4. Multiples of 3 are how many? We know that 33. Plus multiples of 4 are 25. Minus. You have to do minus which number, guys? 8. I'll tell you why. I'll tell you why. Let us check this answer first. So this you will get it as exactly 50 by 100. Look guys, when you check multiples of 3, 33 multiples are there. Which are those? Like 3, 6, 9, 12, what else? 15, 18, 21, 24, 27, so on. When you check multiples of 4, like this last multiple is 99, altogether 33 multiples are there, no problem. So here 4 is there, 8 is there, 12 is there, 16, 20, 24, 28, so on. Last multiple is 100 itself. 25 multiples are there. So we took multiples of 3 perfectly we took. How many? 33, that is fine. Multiples of 4 we took. But if you see guys, there are common multiples, which are those 12, 24, 36, 48, 60, 72, 84, 96. These are common multiples between them. So we are counting them 2 times. We have to remove them. How many are there? If you see which are the common multiples of 3 and 4, common multiples of 3 and 4 means multiples of 12. So which are the multiples of 12? 12, 24, 36, 48, 60. So 72 and then 84, 96. 8 multiples are there. Multiples of 12 are how many? 8. We are counting these multiples of 12 in multiples of 3 as well as 4. So we have to remove 1 time. So that's why -8. Am I clear with this? Did you understand why I am subtracting 8 there? Did you understand that? Everybody, everyone, please confirm. Why I am subtracting 8 there? Did you get it? See Manohar, in multiples of 3, 33 multiples are there, we took them. In multiples of 4, 25 are there, we took them. But if you see, there are common multiples between 3 and 4. Which are those? 12, 24, 36, 48, 72. All the multiples of 12 are common between both 3 and 4. They will be there in multiples of 3 as well as multiples of 4. So we are, what is happening here? We are counting them twice. So these 8 multiples, we are counting them in what? We are counting in multiples of 3 as well as multiples of 4. So we have to reduce 1 time. So that's why I subtracted 8. Did you get it, Manohar? So if you get the difference between 25 and 38, that will work only when they are co-primes. If they are not co-primes, it won't work, Chandana. So don't go with that one. A and B. Yes, exactly, Tarun. You have to remove A. No, no, not every time A and B. I will show you another example. You'll get it. You have to take the LCM and consider all else. You have to consider LCM and all its multiples and all its multiples. Observe. Observe. I'll give you another example. Suppose if I take, suppose if I take 8 and 12. Probability of multiples of either 8 or 12. Check this. Multiples of 8 are how many? 12 are there. Because if I divide 100 with 8, 8 into 12, 96, I can't go further. Or multiples of 12 I can take. They are exactly 8. Now, which are the common multiples among them? Which are the common multiples? What is the LCM? LCM of 12 comma 8 is what? 24. Now you have to check the common multiples of 8 and 12 will be all the multiples of 4. That is 24, 48, 72, 96. You have to remove how many are there? 4 are there. So these 4 you'll be counting in multiples of 12 as well as 8. You have to remove them. So if I remove them, then I'll get my right answer. So what is this? 16 by 100. So here also LCM of 3 and 4 is what? LCM of 3 and 4 is a 12. So that's why we are removing the multiples of 12. Am I clear? Am I clear now? Did you understand this? Did you understand this? Suppose if I directly ask you question in this way, what is the probability of getting a multiple of 2 and 3? It means what? You must get total cases 100. Multiples of 2 and 3 means multiple of 2 and multiple of 3. If you take this as 50 into this as, 33, that will be a wrong answer, because if you see, favorable cases are more than the total cases. That is wrong. So you have to take a common multiple. The meaning of this question is common multiple of 2 and 3. It means you have to check LCM of 2 comma 3, which is 6. Now check multiples of 6. How many multiples of 6 are there? Exactly 16. 16 multiples of 6 will be there, because I divide 100 with 6. 6 into 16 is 96. If I go 6 into 17, that will become 102. I'll go beyond that. So 16 are there. 16 by 100. If you see like multiples of, let's say, probability of multiple of 4 and 3. What do? We take LCM of 3 and 4. What do we get? 12. We'll check multiples of 12. How many are there? 8. So what is my answer? 8 by 100. This is how we calculate this. Am I clear with this so far? Everybody. Everyone. Please confirm. Please confirm. This is the end of probability. This is the end of our next important chapter, that is a probability, people. Okay. So from tomorrow's class, we shall start some brand new concept, guys. Guys, now onwards, I am planning to take all the classes only in the YouTube, so that, the simple reason is to increase the number of viewers in the YouTube, people. That is the sole reason. Can we do that? Can we have all the classes in the YouTube itself? Will that be okay? We shall have once or twice in a week. We shall have in app. Remaining, I am planning to take in YouTube, people. Will that be okay? Yes? Okay, people. Thank you so much. So, and don't forget, guys, whoever are watching, if you're understanding our videos, if you're liking our videos, okay, so please, click on that like button. And if you did not still subscribe, people, if you did not subscribe, please subscribe to the channel. And my sincere request, try to share these videos, at least one video, or try to share our channel among your friends, people, or your class groups or anywhere, so that even other students let understand there are free classes going on. There are free classes going on YouTube every day. Okay, others can also utilize. So this will be the never ending classes, guys. We will be keep on doing the classes without anything, guys. Okay. Okay, Tarun. I will check it out and let you know, buddy. I'll check it out and let you know. Okay, I don't know whether I can do it right away or not, but I'll make sure by morning at least you'll get the solution for whatever the question you sent. You'll get the solution, guys. Okay. Yeah. So we shall stop here, guys. We shall stop here. We shall start with a brand new concept tomorrow. So till then, good night, everybody. Take care. Thank you so much for the class.